Welcome! In this study guide explainer, we're about to supercharge a topic you thought you had on lock. We're moving past the basics of standard costing and taking a deep dive into variance analysis, the next level. So you can probably crush a material's price variance problem without even blinking. But what happens when the real world throws you a curveball? When it's way more complex than just the cost per unit? That's exactly what we're tackling. And look, this isn't just some boring theory. This is about giving you a real strategic edge for your board exams. We're zeroing in on the advanced stuff that's gonna make you stand out. All right, here's our game plan for today. We're gonna start by looking beyond the single unit, then figure out why the old school methods just don't cut it anymore. After that, we'll learn how to totally hack batch-level variances. Then we'll take these ideas out of the factory and finish up with a super fast bullet review for your exam. Let's get into it. First things first, we need to talk about why we even have to go deeper. I mean, the way companies work today is just different, so our analysis has to evolve right along with it. Let's break this down. Traditional costing, the stuff you learn first, is all about the cost of one thing. Simple, right? How much material for one product. But modern factories, they have costs that just don't fit that mold. I'm talking about setting up a massive machine. That one setup cost covers an entire batch of products, not just the very first one. And that, right there, is the key difference we need to understand. So if we're only looking at those per unit costs, what are we actually missing? Turns out, a whole lot. Okay, here's the deal. Standard variance analysis is amazing for things you can easily count per item, like kilos of materials or hours of direct labor. But it has a huge blind spot. It completely misses these batch-level costs. Think about the cost to move a huge pallet of materials, or the time spent setting up a machine for a new production run, or even just inspecting a few samples from a batch of thousands. The traditional methods, they just don't see any of that. So how do we see the invisible? We need a new tool in our toolkit, and this right here is going to be your edge on the exam. I want you to meet your new secret weapon. Activity-based costing, or as you'll see it, ABC. ABC totally flips the script. Instead of the product being the star of the show, the activity is. We're not asking, what's the cost of this thing anymore? Now we're asking, what's the cost of the activity of setting up this machine? Or what's the cost of the activity of handling all these materials? It gives us a way sharper, way more accurate picture of where the money is really going. Okay, that's cool. We've got a new system, but how do we actually use our variance analysis tools, price and efficiency, on something that sounds kind of abstract, like an activity? Let's make it real. All right, let's dive into a case study with Lyco Brassworks. They're trying to figure out the variance in their materials handling costs. This is a perfect example of a batch-level activity. It's basically the cost of all the labor it takes to move materials around the factory floor for different production runs. And check this out. The structure here should look super familiar. We're still breaking down the total variance into a price and an efficiency component. The logic is exactly the same as what you already know, but the inputs we're using are just a little different. Instead of the price of materials, we're using the price per hour of labor. And instead of kilos of materials, we're using the number of labor hours. See? Same framework, new application. So the most important part is connecting these numbers to the actual story. Lyco had a total unfavorable variance over $11,000. Why? Well, first, the price variance. They paid their workers 50 cents more per hour than they planned. Okay, that's pretty straightforward. But look at the real problem, that huge efficiency variance. They used way more hours than they budgeted. And when they dug in, they found two reasons. Their production batches were smaller than planned, which means more moving around, and each move just took longer. This is the amazing insight that ABC gives you. It shows the real problem wasn't just paying people a little more, it was a major inefficiency in their whole production process. Okay, that makes total sense for a factory making stuff. But what's really cool is that this powerful idea works even when there's no physical product to hold. Because let's face it, not everyone is making brass fittings. I mean, how do you even measure the standard cost of a flight? You can't exactly hold it. How do you calculate a materials variance for a hospital stay? The concepts themselves have to adapt to a new environment. And here's how they solve that puzzle. For a company like United Airlines, the key isn't the cost per passenger. Nope, it's the cost per unit of capacity. Their number one metric is something called the available seat mile, or ASM. Just picture it like this. One empty seat on one plane, flying for 1 mile. That's the inventory they're trying to sell. This is the big idea I want you to take away. The focus completely shifts from production volume to how well they use their capacity. An airline wants to know its operating cost per ASM and its revenue per ASM. A hospital does the exact same thing, but for patient days. By comparing the actual cost per unit of capacity to what they budgeted, they can do a really meaningful variance analysis. Okay, deep breath. I know that was a lot. But now we're at the most critical part, how we lock this into your brain for the LECPA. For real, get your phone ready. You are going to want to screenshot these next 2 slides. This is your high-yield summary. All right, LECPA hack number 1, ABC variance. When you see a problem talking about machine setups, inspections, or moving materials, your brain should immediately go to ABC. The formulas have the exact same logic as direct materials. You just swap in the price and quantity for the activity, like labor hours. The price variance asks, did we pay too much for the resource? And the efficiency variance asks, did we use too much of the resource? Simple as that. And here's hack number 2, service variance. If the exam problem is about an airline, a hotel, or a hospital, I want you to immediately shift your thinking to capacity. The key metric is going to be something like cost per available seat mile or revenue per patient day. And remember, for services, it is absolutely crucial to look at both sides, costs and revenue, to get the full story of how they're performing. So there you have it. We've officially leveled up our understanding. The next time you look at a company's financial report or you're breaking down a case study, you're not just going to see the bottom line. You're going to see the stories hidden inside the numbers. So my question to you is, which variance will you spot first?